Nikos, Stefanos, and Nikos, thank you very much for having me here today. Ladies and gentlemen, thank you very much for coming to listen to us. And to the previous speakers, I thank you all. There's been some very, very relevant and stimulating observations and interventions. So, ladies and gentlemen, I am an old man representing an old industry. Why on earth? No, we need to persuade this to work. Aha. Am I too far away? Technology is failing us. Sorry, ladies and gentlemen. No. Okay. Okay. So am I pointing it? Okay. Right. Fine. Okay. So we seem to have something now. Keep your fingers crossed. Hallelujah. Why should you listen to me? Is there any mining left in Europe? No, actually there is. Increasingly today, as globalization, for better or for worse, breaks down, we have to look to our own resources. Europe has, and the organization that I represent, I've worked with Euromines for more or less 20 years. I was its president, re-elected 5 times, and now President Emeritus. I still work with Euromines every day. Euromines represents basically the core and the cream of the European industry. We have world-leading companies, some of which are here in Greece. Europe is a major producer in Greece, for example, of bauxite, gallium, industrial minerals, magnesite, etc., etc. I can come back and explain what some of those things are. Most people have no idea what magnesite is, for example. We represent the cream of European mining. We have large mines, small mines, we have equipment manufacturers, we have consulting firms. What's very interesting is that Europe leads the world in the technology of our sector. That's really important to understand. Some years ago I did a study on behalf of the European Union with colleagues, and we looked at the trade relationship between Canada and the European Union in terms of the mining industry. So obviously Canada is an enormous country with vast resources, and the vast majority of trade flows were going one way. But very interestingly, the intellectual flow, the flow of services, the flow of intellectual capital was very much the other way. So what's happened? This is a graphic that serves to illustrate various things. There's lots of pieces of legislation. Europe is very good at issuing legislation. We live with regulations and legislations. When in doubt, issue a new law. That's what the European Union does. But it is responding to a crisis. The Critical Raw Materials Act represented the first step following the Draghi and Letta reports in terms of addressing a crisis that Europe faces. In a global economy, OEMs generally don't keep very much in the way of stock, inventory, stockpiles, whatever. OEMs, for example, don't buy rare earths. They buy components that have rare earths. So they have a stockpile of what? 12, 14, 15 days? And when our Chinese friends decide that they want to turn the tap off, that's a problem. Increasingly a problem today. Europe has already been held hostage once due to the conflict in Ukraine. We've changed, we've diversified our energy supply, and we are all paying for it today. Energy prices are enormous in Europe. And one of the reasons we are responding to this crisis is to decarbonize. Europe will never be competitive unless we decarbonize. And in order to do that, we must make a technological shift. This is most people's idea of what mining looks like, even today. This is from a book published in 1941. You're probably familiar with the artist. It's Richard Scarry, an American artist. You probably all read his children's stories when you were little. I have a friend, his name is Jon Mostrom. Jon Mostrom is the CEO of LKAB. What is LKAB? LKAB is the largest iron ore producer in Europe, has the largest underground iron ore mine in the world. It produces 80% of Europe's iron ore. It doesn't produce rocks, it produces iron ore pellets that will go to blast furnaces, to steel manufacturers. Jon was an unskilled miner. He's now 65 years old. He's retiring in a few months' time. He was an unskilled miner. He was the machine. He worked with his hands. He financed himself through university. He became a mining engineer. He worked his way up. He became a mine manager. And now he's running the most modern iron ore mine in the world. He now uses the machine. Within this decade, we will see mines in Scandinavia that have no human beings working in them. They'll be working upstairs, but they won't be working downstairs. Robots will be doing that. I want to give you a real example. DPM Metals, which is a company I've known since it was born. Literally, by bizarre coincidence, I was the very first person to telephone this company on the day of its birth. It's gone from zero to being a responsible company with a worldwide reputation for excellence and innovation. It's a Canadian-listed company. It's gone from zero to a market capitalization of about $9 billion. It's got about $1 billion in the bank. By anybody's measure, it's doing okay. It's very well thought of, both by its hosts in terms of the countries where it works with, by the people it does business with, and by its employees. I'm not going to go through their data. That will be available through the organizers. It works across various locations, but what it does is it uses local skills. They don't import regiments of Australians or South Africans or Canadians. What they do is they train people in Ecuador, in Serbia, in Bulgaria, and they deliver quality throughout. If I look at Chelopech was a mine that was built originally during the socialist period. A planned economy. It wasn't built for commercial reasons. It was simply built to supply commodities. This is in the Balkan mountain range, not too far from Sofia. So the local geography to you. It's polymetallic. It produces a suite of metals, but the most valuable ones are copper and gold. You can see a shaft through the middle called the Kapitalnest shaft. I visited that shaft in 2004. There was a safety campaign going on that day, and the chief electrician was going to run it. He was dead by the afternoon. It tells you something about how different things are. They haven't had a fatality in the last 20 years. Things change. Mining used to be a very dangerous industry. Today, through our greater understanding, through the use of technology, it is becoming a much more interesting and a much safer industry. What do people do? The number of employees is the only really important one. In 2004, is that 2005 down there? 2004 is when I first got involved. There was a vast number of manual workers. The vast majority of the people working at Chelopech today are people who work with technology. And I'll explain that a little more now. So, for example, what we need to do is you don't just arbitrarily dig in a mine. You're looking for something of value. It's a commercial operation. And, you know, little boys like to play with shovels and things. That's true. But we do things in a commercial way. We're engineers. We're scientists. We need to have precision. You're not digging up a metal. You're digging up a rock that you're then going to do something with in order to deliver a product that somebody wants to buy. So you need to know where it is. So what do we use today? We don't send some guy down with a little hammer and a light on his head. We send a drone down there. And here's a little video. Oh, you get music as well. I can talk you through this a little bit as well. You know what a drone does. You know what it looks like. You can see some dust there. You can send the drone through immediately after blasting. You can't do that with a human being, unless you want to have a rescue team waiting for him or her at the other end. The drone can use digital technology very fast. It's all built in on board. It has a database connection. Generally, your geologist doesn't. The geologist is very skilled, but he or she is much better at interpreting the data than actually collecting it. So the drone not only can work at a faster speed, it can use time that you weren't able to use as a human being. It can deliver results much faster. And today, what we're really concentrating is not, what kind of drone to use, but what to do with the information that it brings back to us. And as you can see, this is not a medical object. This is actually a picture of the ore body and what's going on. So the idea is that you develop a sustainable mine. What the hell do I mean by that? Sustainable mine? That's a contradiction in terms, isn't it? Something that can be used in the future. That's not supposed to have happened. Oh, here we are. So anyway, so the idea is that we will leave enough in there for future generations to use. So what do you do next? So you'll drill. So this is a gentleman that's using something called a jumbo. It doesn't look like an elephant. It's a large drilling machine with various drills on it. It's appropriate to this type of mining. I won't go into any further detail. But again, you're using technology. So this gentleman here, I don't know how old he is. He's probably in his mid-30s. He probably never worked underground, but he knows how to work the machine, but he's also got skills as probably a gamer. So he knows what needs to be done, and he's using it. I've done this at Chelopech. Sorry, that shouldn't have happened, but okay, we'll manage. I've done this at Chelopech sitting in Toronto. I've actually done that. I've worked the jumbo sitting 3,000 miles away. It doesn't matter where you are. Rio Tinto is doing operations from Australia in all parts of the world. It's normal now. So again, you're removing people from the hazard. You can move to an autonomous regime. At the moment, it's largely semi-autonomous because we need to build up the knowledge. But again, you're using time and resources much better. So you've found it, you've drilled it, you're going to blast it, and what do you do next? This is a loader. This is the thing that will take the material out and then deliver it to a chute or a conveyor belt. So again, hopefully this is working. Now, the wonderful thing about this is you can operate a small fleet of these now using ever-developing technology with only one person. You don't need to have a pair of people on each machine. You don't need the maintenance team down there because you're also monitoring the machinery itself. So it becomes somewhat of a social experiment. How do we deal with the fact that, perhaps jobs are being taken away? Are they really? I don't think so. I see jobs being created. This is in Bulgaria, by the way. And I don't think you need to see, you can see him playing with the rocks. As I say, boys like to play with rocks. So moving on to the next one. I'm a little bit sad about this because I'm going to walk over here for a moment. Over here, there's something else in this control. Over here is a board, a simple plastic board with magnetic stickers on it, little discs. Those little discs are for the mines inspectorate, for the safety people, because they don't understand this. The Bulgarian mines inspectors do not understand what the hell is going on here. So they need discs to show that where people are in the mine, their first concern, rightly so, is where are people in the mine. So you have a fully digitalized system of knowing exactly where your staff are because everybody has some sort of digital tag. And you're not only predicting the amount of time you need for people, you're able to keep an eye on them and take care of them properly. You're not, for example, having to do frequent alco testing because you know what? People learn after a while. It's not just machine learning, it's the interaction, as Milan said very well. It's that companion interaction. So we've got short data intervals here. What we have here is a control center. Everything, the real value in any mining operation is in the processing. We produce products. We don't produce rocks or metals. We produce very specific products that customers need. And what do? You have the interaction between the technology, which is creating more information for you to then use to develop further, and the experience and the training of the operators. Here is where process engineers are working, not gamers. You see the same at the iron ore mine that I mentioned earlier at LKAB. You don't have gamers working here. You have process engineers, you have mining engineers, developing knowledge and developing fixes as they go. This is very much a bootstrapping approach. So you have data-driven models, as I've just described. So you have the results. They're seeing results. They're seeing results because they've got $1 billion in the bank. Bottom line, ladies and gentlemen. Our industry has been perceived as being very slow. It is, in many respects, because it's a capital-intensive, long-term industry with long traditions based in long-rooted communities. But when you deliver this type of job opportunity, this type of change, this need for more different suppliers, this generational change to communities, it's really exciting. We don't kill people anymore in our industry. Not even deliberately. We're not allowed to do that. Our health and safety rates in Europe are the best in the world. Our technology is the best in the world. We are picking up on AI. I can't say that we are the best, because I would say that you have some wonderful examples of large-scale projects in Australia, for example, where AI is being deployed very effectively. So I'm conscious of time, and I'm doing okay. But basically, coming back to what we're doing, it's all about delivering results, and the use of digitalization, the use of AI, the openness to taking on examples from other industries is really delivering. And I wanted to give you a very specific example to show that. So, as a parting slide, this is Spot. Now, Professor Paspaliaris is here somewhere. I hope he's still here. Ioannis, are you here somewhere? He's hiding. Okay. Professor Paspaliaris is from the National Technical University of Athens, and he's very fond of using the cartoon character Spot. This is an AI-driven mining aid. This is used at LKAB. Spot can basically get to places where human beings cannot. You don't need a drone to do some things, but Spot could save your life. Ladies and gentlemen, thank you very much.
Mark, thank you very much. I would normally ask the audience for a question, but it's a question that I really want to make. You have shown us some impressive technologies. Underground drones, robotic dogs, all of them are either powered by AI or assisted by AI. However, we know that Europe is facing unique costs and regulatory pressures. So my question is, where the sector should place its digital bets in order to be economically viable against global competition?
Nico, thank you. Look, I watched a very interesting webinar from McKinsey a couple of nights ago. It's one of the things you do when you work across time zones. And it was about competitiveness and how value has changed, how wealth has changed in the world. Europe has a competitiveness deficit, absolutely. So how do you address that? We have to address it by change, and that has to be technological change. You know, we can't talk about moving people or reskilling people quickly. It has to be a technological change. What can it enable us to do? It must enable us to do what we already do well. So we need to deploy AI much more effectively in value chains. And what does that mean? Understanding them. I said repeatedly in my presentation, we mine rocks, we don't mine, nickel. You don't just produce a piece of nickel. So when the European legislator says we need to secure the supply of, let's say, nickel, you don't mean that. You mean nickel sulfate. You mean other things, derivative products. So without AI, without greater digitalization that allows us to understand that, to build a little bit of time for us to build our industrial capacity, we will not succeed. So there's your answer.
Thank you. Thank you very much. Thank you, Mark.